Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is a little project I worked on over the weekend using RC522 and a SG90 Servo. Let's kind of look at what this is. So I'm going to start this code up here and show you what this does, and then we'll go on from there. Okay, there you go. I turned it on, and let me point to the modules that we're using here. We're using the RFID RC522, right where my finger's pointing, the SG90 Servo, an SSD 1306 display, the Pico W, and two LEDs. Sorry, I moved the board. I'd like to fasten that down, but okay. So if I take the card and I place it over the reader, two things just happened. Well, actually, total of three. One is the servo changed to a 0-degree angle. The green LED light came on, and on the SSD it showed unlocked now, and it gave us our car reading. I have a fob RFID reader too here. You can see the fob. If I place it over the reader, you can see it moves the servo, and it turned on the red LED. The reason why it turned on the red LED is because now the SSD is saying it's locked, and you can see that the card number is actually a different number. The RFID chips run off of a different hexadecimal numbering system inside of it. In the code, we converted over to the bits, but it is a coil of wire wrapped around inside this with a small MU in there, or MC that has a small amount of byte data that you can store inside of it that would have the hexadecimal in it. With the code, the library that is in this, you can actually go in and change your own. This is the same as with the card. The card has a coil with an MC in there that you can change also with the data storage. Alright, let's go to the wiring diagram instead of go from here. Hey guys, let me switch up the wiring diagram. Here we go. Alright, the components that we got here is the RFID RC522 that my mouse is pointing on. Let's see if we can actually enlarge this. Hey, there we go. It might be a little bit too big, but we'll move it around here. Alright, we're going to get the pins out, and you can see the Pico W right here. And so we're going to start with the far left pin and work to our right. And that is an SDA, and it goes to pin 13. Come right down here to the Pico W. The other one is an SCK, and it goes to pin 10. You can see it, the yellow wire wrapping down here. Then we have an MOSI going to pin 11, which is right next to it. Then we have an MISO going to pin 12. And then the IRQ is not used. That's if you were making a final project out of this, you might want to use that, because if you put the RFID RC522 to sleep, this is the way how you wake it up, is through the IRQ. But since this is just a little project that I'm working on, I'm not making it to a final one at this time, so I don't have it hooked up. But if you did have it hooked up, you'd want to hook it up to another pin, and inside your code you would specify that to activate for a wake up. So when you put it to sleep and save into energy mode, you need to wake it back up. Next one is a ground, and we're using that to the ground rail. And then the next one after that is an RST, and that's going to the pin 0, and that's to reset the board in case if there's any problems with the code that's caused it to lock up. And then our 3.3 volts is running to the power rail that we can see from the power rail coming right here. Now let's move this around a little bit more. We'll go to the far left in our servo. So we have our black hooked up to our ground rail coming off of the Pico W from the ground pin on this side of the Pico W. And then we're coming off of this 5 volts coming off if you're using a USB. If you were going to hook this up to a battery to power the Pico W, you'd have to have an external power supply, because the Pico W does not push out 5 volts out of it. It's only 3.3 volts that comes out of Pico W. But since we're using a USB, we're going to go ahead and take advantage of that 5 volts that's there, that the Pico W does push out. And then that goes to the red line that come to the servo, and then our yellow line comes over here to the pin 15 that we're using. And now let's switch over here to the red LED. The red LED is coming up here to pin 14 with a 330 resistor and the cathode running to the ground. Then we have a green one hooked up to 330 ohm resistor, and we're having to jump all the way up here to there we go. We're using the GPIO pin 9 right there on that one. Sorry, I spaced out and forgot because we got ground right here in the middle of that. That's right. And now let's go ahead and look at our SSD. This is the same style of SSD that I showed with the other projects I've done, but then this one compared to my actual layout is different. So this one says we're using VCC first, so I got that connected to the power on the power rail. Then our ground going to the ground rail, and then the SCL, and that's running all the way over here to well, here we go. Wait, let me grab all of this and then make it easier for all of us. Let me scroll it up where we can all see that a little bit better. And then we're using the SCL going to pin 5 over here, and then the SDA going to the pin 4, which is a blue one next to it. We're throwing a 3.3 over here to the power rail from that one side of the PicoW, and we're hooking up to the ground on the other side of the PicoW for the rail. That would have everything there hooked up. Now let's go over here to the code, and I'm gonna try to make this one a bit larger here for you guys too. Bear with me here. There we go. You should still be able to see that. I'm gonna lower this down. Whoa, wrong one. Try to grab out that window. There we go. And I'm gonna go ahead and stop this because we're not using it at this time. And let's scroll up here to the top. And this is just a little description about what it is. It's a little project I was playing around this weekend with. And then now let's go to what we need to import here. I'm importing from the MicroPython const because these values are not going to change. Go ahead and keep it so they don't change by any function or any mishaps I might have done or any kind of bug that might try to change the pin. So I went ahead and cleared my servo pin that we talked about in the pin layout. So I'm just going to really skip over these because we've already done that and I don't want to waste very much more time with that. Now let's get here to two things down here. One of them is locked is true. That's going to be a function that we're going to use. And the lock state, which I don't think I'm using lock state anymore, so let's just bypass that right now. Create the object. We're going to create the SSD object, which is an I2C that we brought in through the library. Which I'm sorry, I ran through the library so fast. I should have went back here. In the machine, we're importing pin, PWM, the SPI, the I2C, and the soft reset. Which I think the SPI was another module that I was going to hook up, which I didn't. That's why it's kind of a different color because I'm not using it at this time. And then the SSD 1306 is being imported from inside the PicoW library. If you look over here to the far left, I got it scrolled down here, and you can see right here in this library. You need to put it on your PicoW library for it to work with the PicoW. I do have it up here with my other ones, but it's also in the library. And then we're also importing from the PicoW the RC522, and this is actually the card reader library. And then we're importing UTime as time. We'll be using UTime for a delay, so when it reads the card, it takes 2 seconds in between. Therefore, it won't constantly read it super fast, and it just makes the servo go back and forth. So that's not what we wanted. We didn't want it to unlock and lock at the same time we touched it. All right, now back here to creating the objects. We created our servo object, which is a pulse width modulator, and we added in the pin that we stated up here in this pin. And then we're setting it to the frequency of 50. The servo runs off of a frequency of 50 because it's a pulse width modulating. And a pulse width modulating means that 0 degrees is 1638. And if you do the math, then you over here to the 180 would make it 8191. That's with pulse width of 0.5 milliseconds out of a 20 millisecond window that it looks at. So at a 0.5 milliseconds, if you do a signal at 0.5 milliseconds, you're saying at 0 degrees. If you're doing a pulse width of 2.5 milliseconds, you're saying turn to 180 degrees. That's where we got the numbers set up at. I could go into more details of the math, but I just kind of wanted to show you the function. You can just copy off what I did. I might do an addition to this so people can start running the math that is involved with the servo in a pulse width modulating. Next one is doing the object of the reader, which is using the RC522. We're including all the pins that we had laid out that was actually on the wiring diagram, plus that we have set out here as a variables with the const. We're having to add all those into here, and it uses the library. It's already in the Pico W to activate that. Then we added the two LED pin or LED lights. We get the red and the green, and we initialized those being as pin out for both of those. And the functions, my first function here is used to center the text on the SSD 1306. It's just taking the text as an argument and taking that text and timing it by 8 and divided by 2, then minus 64 of the middle of the to get the middle of the text, and then returning the middle of that text, or returning the text that we had done the math formula on. Our next function is to set the lock. We're taking the argument of locked as either true or false. I want to know if it's locked or not locked. And to save bringing in so many arguments, I went ahead and we're doing a global find for the LED red and the LED green, which is the two different objects that we created for the LED lights. And then now we're asking here in the if, we're saying if it's locked, if that's true, then we're going to turn the servo to 1638, which would be to 0, and we're going to shut off, make sure that the red LED is shut off, and turn on the green LED. And then we're going to display onto the SSD the status of unlocked, or the message unlocked, and then I'm using calling in my function to center it. Now if it's not locked, if it's not true, then we're going to go ahead and have it lock itself over at going to 8191. It's going to give the red LED to come on and shut off the green and display locked on the SSD. Then we're doing an LED status. When you very first start up your program, I want it to be able to read the servo status and then activate either the red LED or the green LED, as you see in the arguments here. So then when you're using the red LED, means the LED red object. Green LED argument is bringing in the green LED object. Other than global, like I did with the last one, I did it correct. Okay, and then we're doing the servo status as an argument, and that is actually servo duty unassigned 16. We're wanting to read that value. Now we're saying if that value says 8191, turn on the red LED. And shut off the green. If it's not 8191, which would be the 1638, then we're going to turn on the green and shut off the red. Now we're going to clear our SSD, and to be able to do that, we have to do the show after we fill it with all zeros, meaning shut off all the pixels. Then we're going into our while loop, but we're going to do a true and except, but inside that, we're going to say while true, which is a continuous loop until we terminate it, or until it runs an error. We're going to initialize the reader, so we're activating it. We're saying, okay, use that object now, okay, and turn on the antenna. Make sure the antenna is activated and ready. That's it's going to check all that in the library of wrong library. It's going to go in here and look in the library, and it's going to see if the antenna is activated and on. This is a really big library. I should have had this already set to it. There we go. And then we're going to come in here and we're going to verify first of all what board we're using. Either a Wi-Fi or an ESP or a Raspberry Pi. And if it's not one of those in this library system, then it's going to say unsupported platform. and then it's going to make sure the reset value is correct and set on. It's reset it. It's going to read the register and write. That's the write and read, and then to set the flags for the correct, and then copy the flags and then to the card. These are going to receive the bits and take in the wait or the wake up or the non-wake up argument is what this one would be for. And that's all the status for that to wake it up. And then we're wanting here to initialize, and we're going to see if the antenna is set on. So now back here, so we're saying, okay, is it on and awake, and is the antenna ready? Then we're going to go ahead and read where our servo is at and activate the LED because we just turned on our program. And then we're going to display if it's locked or unlocked based on where the servo is located at. And then we're going to display onto the SSD card to read, place the card to the reader, is what it's pretty much saying there. And that's what this little block of code saying. And then our next one is here is we're going to access the address on the card when you place it onto the card reader. And you're going to check to see if the card reader is activated and that the antenna is activated. And then we're going to see if the card is the correct style of card that can be used with the RC522. And if it is, then we're going to go ahead and continue down to the next block here. And it says if that's correct and it's been read correct and there's no errors, we're going to head and clear our SSD, and then we're going to grab the data from the card and put it into the a function called, or into the variable called card, and then we're going to convert the hexadecimal into bytes through that card reading, and then we're going to display that information onto our SSD. And plus, we're going to print it out. So if you download this, I'll have this on GitHub, but if you download this, and your card will not be the same number as mine, so I have a printout here saying print it as a string, the card information down below. As you can see down here, this one was the credit card style, and this number right here was the fob that we used. So you can see there are two different numbers, and that's what it will print out. And you'll take that, and right here in this string, that you'll change that to your actual card number, and for it to be able to read this block of code, for it to be able to turn the servo, because this is the block of code that here that activates the servo. So it says if that card is this number, go to the servo. If the servo is at this location, which is 180 degrees, then we're going to run the function set lock. As we saw in the function up there, we're using if it's true or false, and we're saying it is locked because we're saying if it's at the lock status, which is now would be true, we're going to run the code and unlock it. Oops, I passed right past it here. And then we're going to run this block of code right here, and we're going to unlock it. And then, sorry, the dog's sleeping back here, having a weird dream. It's barking. Okay, right back here, where was that? Oh, I got lost. Here we go. And then we take that information and oh, yep, right here. And then we're going to do a 2-second delay in between reading the card and moving the servo. Therefore, it does not cause the servo, like I said before, to activate on and off super fast. If it's false, it does the same thing, and it will lock it, and then it'll display the information onto the SSD. And then now if we're using the fob, and that's just the block of code for the fob, then it'll do the same thing. If it's asking if it's at 180 degrees, which will be the lock indication that I specified as 180 degrees, then it will go ahead and unlock it, and then have a 2-second delay. Same thing if it's unlocked, meaning at 0 degrees, it will turn the servo to the lock position, or the 180 degrees. And then we'll have a total in the whole loop of while true loop, 500 milliseconds to be able to run through that cycle loop. Now if we go ahead and hit stop, which I already did, what that does is it's going to set the board to all zeros and set that to display, and then shut off the green and the red LEDs, and then do a soft reset on the Pico W. And so it's all prepped and ready for us to run it again. Like I said, I'll have this code along with the 2 libraries that are needed to run this. If you use a SSD 1306, you'll need to use that library right down here, the SSD 1306, and the MFRC522 to be able to do that. Now this RFID access.py is if you wanted to read the card data and then change that card data to that to the MC on that either the fob or your card or whatever you have that would be as your RFID reader or transmitter. But I did not include it in the GitHub because I didn't really had it set up as this project. Because that is some additional coding that we would have to do on our side to be able to convert that and change that. But what I do have on the GitHub now is for you to be able to do what I did and I showed at the beginning of this video. If you have any questions or comments, leave them down below. Thanks for watching. Until next time, be safe out there, everyone. Until next time. Bye-bye.